Sorry. So if it's an absolute value and it's equal to, it's going to be an OR statement. If it's an inequality, if it's a greater than, it's also an OR statement. But if it's a less than or equal to, it's going to be an AND statement. So if we have the absolute value of 6x minus 3 equal to 15, all I'm going to do is I'm going to write out two separate problems. But now, whenever I'm writing out two problems, because it's an absolute value, the first one is really just going to repeat what is listed. So I'm going to have 6x minus 3 equals 15. My second statement, because there is a positive and a negative value, then I'm going to solve it for, I'm going to have an OR 6x minus 3 equals negative 15. Because there's a positive and a negative value for each. Now, the way that I would go about this, you have two problems. The only thing different here is going to be your answer. Your steps and what you add and subtract and multiply and divide should not change here with an absolute value. Because you have the same thing. You have the same values. The only thing that's different is one of the values. And one of them is going to be positive. The other one's going to be negative. So the way that I would go about this to kind of help save you time and a little bit of effort is, what are you going to do to the one on the left? How are you going to solve for x? Add 3. So if I add 3 to the first one, so if I add 3 here and here, I'm going to do the same thing on the other equation. So 3's are gone. I'm looking at 6x equals 18, and then 6x equals negative 12. What I do to each side isn't going to change. I had to add 3 to each one. I'm going to now divide 6 by each one. The only thing that's going to be different is my answer. Okay, I'm going to have two different values. I shouldn't have different values, or excuse me, the same values. So I'm going to divide by 6, same way on the one on the right. So then my answer is just going to be x is equal to 3 and x is equal to negative 2. It's one or the other. It doesn't have to be both, but those are the two answers that it can be for this statement to be true. Now, whenever we have an absolute value, so like it said at the very beginning, it is, I still need to solve, I need to get the absolute value by itself before I do anything. So what am I going to do to get the absolute value of 4x minus 9 by itself? What do I have to solve? You treat it just like a grouping symbol. So what do I have to get rid of first before I do anything? Get rid of the 2 and the 4. But what do I need to get? Which one do I need to get rid of first? Get rid of the 4. So I'm going to add 4 to both sides. So I have 2, the absolute value of 4x minus 9 is less than or equal to 26. Now what do I need to do? Divide by 2. So I'm looking at the absolute value of 4x minus 9 less than or equal to 13. Now, the reason why I want to get the absolute value by itself first and not just set it up and go is because it may flip my signs and it may turn it from an and, like in this case an and statement, to an or statement. Now, with this, if it's a less than or equal to, is it and or? And. Okay? So it's an and statement. Now, the and statements are the easiest of any of these. Because all you're going to do is take this part right here, and all I'm going to do is rewrite it. I'm going to rewrite it up to the right. So I'm going to have, and I'm going to drop off the absolute value. Instead of writing two different problems, I'm going to write 4x minus 9 is less than or equal to 13. Now, here's where I'm not trying to lose you. I'm trying to make this a lot easier for you. Is all you're going to do is you're going to put a less than symbol out in front. Okay, instead of writing two problems, to make this easier, I'm going to write a less than symbol out in front. And then whatever this value is, so it's 13. On the problem before, what did we do? We had a positive version of our number and we had a negative version. So I'm going to take that 13 and I'm going to make it a negative 13. And statements are easier because it keeps everything in the middle, it keeps my variable in the middle, and I don't have to write out two separate problems. I'm going to do everything at the same time. Remember, like we talked about last week, whatever I do to the middle, I have to do to the left and the right. So what am I going to do to get the x by itself in the middle? Add 9. And then divide by 4. So I'm going to add 9 to every single part. So I'm at negative 4 less than or equal to 4x less than or equal to 22. Now we're going to divide by 4. So I divide the middle by 4, I divide the right by 4, and I divide the left by 4. So in doing that, I have negative 1 less than or equal to x less than or equal to 11 over 2. Again, just leave it as a fraction. Now, if I would actually have to graph this, what would my graph look like? Would it be, first off, would it be open or closed circles? Closed circles. Would it be shading inside or out? Inside, right? Because remember, it's real simple. Where's the x at? It's in the middle, so that's where I should shade. How am I going to write this in interval notation? What are my two values? Negative 1, comma, 11 over 2. What am I going to put around it? Parentheses or brackets? Why brackets? Because it's equal to, right? Okay? Because it's equal to. Problems. So, can I go ahead and start separating it out yet? No. What do I need to do first? Add the 8 to the other side. Okay, so if I have plus 8 and plus 8, I'm dealing with the absolute value of 8x plus 28 greater than 40. Now, is this going to be an and or an or statement? An or statement. Okay, so this one's going to actually be written out as two separate problems. Do not write an or statement like you do an and statement. Okay? You're not going to put this in the middle and go greater than and go 40 and negative 40. That's not how it's going to work. Okay? The only one that's going to have its own single line is going to be the and statement or the less than or equal to or the less than. If it's greater than or equal to, you're going to separate out. You're going to rewrite basically this whole problem of x plus 40, or excuse me, plus 28 is greater than 40. And then you're going to rewrite in the other one 8x plus 28 is less than negative 40. What changed from the black one to the red one? Did the part inside the absolute value change? No, the 8x plus 28 didn't change. What did change though? The symbol and the sign, right? Of the 40. So a positive and a negative. So if you have a greater, you're going to have a less than, or a greater than or equal to, or a less than or equal to. If you have a positive, then it's going to be a negative. Just like we did before, this is an or statement. You can write it all out at the same time. So what am I going to do first? Subtract 28. Do the same thing on the red one. So I'm going to have 8x greater than 12, or 8x is less than negative 68. Now what? Divide the 8's. So what's the one on the left? X is greater than 3 over 2. Or x is less than, what's 68 over 8 going to reduce to?
Negative 17 over 2.
What?
Negative 17 over 2.
Negative 17 over 2. So it is an or statement. So basically I'm going to write it like this if it's in just inequality form. Now, if I write it in interval form, one of them's going right, one of them's going left. If you have it in interval form and it's an or statement, you're going to have one going to negative infinity, you're going to have one going to positive infinity. So, which one, let's just go ahead and start it off first. Which one's coming from negative infinity and then going to that number? The negative 17 over 2, right? Is negative 17 over 2 included? Is it a bracket or a parenthesis? Parenthesis. So negative infinity to negative 17 over 2. Or 3 over 2 to positive infinity. Get accustomed to writing it in interval form. Okay? Inequality form is great, but you're going to use interval form a lot more than you do anything.